Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about solid mechanics and material subject. So in this subject already we have in previous session discussed about principal stresses and strains. Now in this session I want to discuss about problem solving. So how to solve the problems on principal stresses and strains. So already some equations we have derived and empirical formulas also we have studied in previous session. Now those formulas and equations how to apply for the given problem we will see today's session. So first of all we should discuss about course outcome. So at the end of the course students should be able to demonstrate the principal stresses, principal planes and torsional stresses acting on any arbitrary plane within a structure using analytical and more circle methods. Already we have discussed in theory part. So in this session we will see the problem solving, and already the student at the end of this problem solving the student can able to solve the problems and also demonstrate the principal stresses and principal planes and strains by using a graphical method and a theoretical method. So the problem 1, the principal stresses and strains. So in this problem, what he has given, a tie bar is subjected to a uniform tensile stress of 100 Newton per mm square. Find the intensity of normal stress, shear stress and resultant stress on a plane, the normal to which is inclined 30 degrees to the axis of the bar. So also estimate the maximum shear stress in the bar. A tie bar is given, is subjected to uniform tensile stress. The stress is 100 Newton per mm square. What he has asked, find the intensity of normal stress and the resultant stress. On which plane? The principal plane, that is 30 degrees to the inclination 30 degrees to the axis of the bar. Also finally calculate the shear stress. Here shown in this figure, the given tie bar is subjected to tensile load, so that the tensile stress given, and the inclination plane is theta, shown here the PQ. So that is a theta angle 30 degrees to the axis of the bar. So axis of the bar 30 degrees. Now, so how do you calculate the normal stress? So normal stress equation already we have seen and discussed in theory session. The normal stress is equal to sigma into cos square theta. Sigma n into sigma into cos square theta. What is sigma? The sigma is 100 Newton per mm square, that is uniform tensile stress. If the given stress is 100, then uniform tensile stress into cos square 30. So the theta is, the inclination angle is 30. So here calculate cos square 30 and substitute value in this. Root 3 by cos 30, value root 3 by 2. So that 3 by 4 multiply with 100 will get 75 Newton per mm square. So now the tensile stress along this plane sigma by 2 into sine 2 theta. The sigma is given 100 Newton per mm square tensile stress by 2 into sine 2 theta, that is 60, 43.3 Newton per mm square. The sine 60 root 3 by 2. The final resultant, so what he is asked, the intensity of normal stress already calculated, shear stress already you calculated, that is the sigma t, sigma by 2 into sine 2 theta, and then the resultant stress on a plane is square root of sigma n whole square plus sigma t whole square. Already we have calculated the sigma n. Sigma n is equal to 75 Newton per mm square. Sigma t calculated 43.3 Newton per mm square. So now substitute these two in this equation. So we will get 86.6 Newton per mm square. So the maximum shear stress at 45 degrees will be occur. That is, the maximum shear stress is 100 by 2 sigma by, that is sigma value by 2. So that is maximum shear stress occurred on a principal plane. So next problem. So in first problem we have calculated directly by using formulas. And second problem we will see a tension member is formed by connecting with glue two wooden scantlings, each 100 mm by 200 mm at their ends, which are cut at an angle of 60 degrees. 60 degrees as shown in figure. I will show you that diagram. Two wooden slantlings, the dimensions are 100 by 200. So which are cut at an angle of 60 degrees. The member is subject to a pull P. Calculate the safe value of P. If the permissible normal and shear stress in the glue are the permissible normal stress 2 Newton per mm square and then shear stress 1 Newton per mm square. So how to calculate? We will see. This is the diagram. That the given diagram is formed by tension member connecting with glue two wooden slantlings. The glued joint is shown in this diagram. The dimensions are 200 by 100 and the angle is 60 degrees. From its axis, that is theta 30 degrees. Now we have to calculate stresses on this AB plane. So the area, rectangular section area 200 by 100, length into breadth 220,000 mm square. The angle of cut with horizontal cut angle is 60 degrees. But the angle of cut vertical 90 minus 60, that is 30. The horizontal cut is angle 60 degrees, but the angle of cut with the vertical is 30 degrees. Now apply the formulas. Here given, what he has given is sigma n given 2 the permissible normal stress 2 Newton per mm square given, and then shear stress also given 1 Newton per mm square. Clear? But in previous problem not given these two. So we have calculated the sigma n and sigma t shear stress. Now given directly here values, and we should use formulas. Which equation is suitable for this problem? See, the sigma n, already you know, the sigma n is equal to sigma into cos square theta. But in this sigma we have to find the normal, stress, the tensile stress not given. So the sigma is equal to sigma square, sigma n into secant square theta. So otherwise here you can take directly sigma n by cos square theta. So you can write 1 by cos square theta term secant square theta. 2 secant square theta, theta is 30 degrees in vertical cut. So that the cos 30 root 3 by 2 and secant 30 the inverse 2 by root 3. So now 2 by root 3, 2 multiply with 4 by 3. So you will get 2.667 Newton per mm. So sigma t is sigma by 2 into sine 2 theta. So in this, in shear stress is equal to sigma by 2 into sine 2 theta. Sigma we don't know. The sigma, calculate 2 sigma t by sine 2 theta. Sigma t is 1 and sine 2 theta is 2.309 Newton per mm square. So here, according to the tensile stress, we got the sigma, according to the normal tensile stress, we got tensile stress is 2.667, and then according to the next shear, what he has given, then the shear stress formula, we got sigma is equal to 2.309. So now fix the final value by seeing the above two values. The sigma we select the lesser of two values. The safe stress sigma will be lesser of two values. So which one is less? This is 2.309. So take this value as a final value. Now we apply stress equation. Stress is equal to load per area. So stress, tensile stress is equal to load per area. Load we don't know. We have to calculate. So that is sigma into A. Area already you know, and sigma also calculated. So we got the load value 46.18 kilo Newton. What he has asked? Calculate the safe value of P. So what is the safe value, that is load? If the permissible normal and the shear stress in the glue are 2 Newton per mm square and 1 Newton per mm square respectively, then calculate P. Already we have calculated P. So like this need to solve this type of problems. Next one is third problem. Say rectangular bar of cross sectional area 10,000 mm square. The rectangular bar area is given. The given area 10,000 mm square is subject to an axial load also given 20 kilonewtons. So determine the normal and shear stresses on a section which is inclined at an angle of 30 degrees with normal cross section of the bar. So this problem same as the first problem. So here normal stress not given, you have to calculate, and shear stress also not given, need to calculate by using this given data. See, already you know stress is equal to load per area. So load already given, area also you know, so calculate. So directly formula substitution. So sigma n is equal to sigma n is equal to sigma into cos square theta. Normal stress. So sigma value 2 and cos square theta is 30 degrees. So the given inclination 30 degrees to the with the normal cross section of the bar. So that so substitute the cos square 30 value root 3 by 2. Clear. So that is 0.866 whole square. So the final value will get 1.5 Newton per mm square. Sigma T, that is sigma by 2 into sine 2 theta. So 2 by 2, the sigma value, stress value already got 2 Newton per mm square, substitute in this equation. So 1 into sine 60. Sine 60 value also root 3 by 2. So substitute, you will get these two values. Then formula substitution. This. So next problem, the problem number 4. In this, at a point in a strained material, the principal stresses are 100 megapascal, that is tensile, and 60 megapascal, that is compressive. Determine the normal stress, shear stress, and resultant stress on a plane inclined at 50 degrees to the axis of the major principal stress, and also determine the maximum shear stress at the point. So in this, the principal stresses are given. The sigma 100 MPa. So convert into Newton per m square, and sigma 2 60 megapascal. This one also 60 Newton per mm square. So actually the 100 megapascal convert into 10 to the power 6 Pascal, and 100 into 10 to the 1 Pascal is equal to 10 to the power 6 Newton per meter square. One Pascal convert into mm square divided with 10 to the power 6. You will get 100 Newton per mm square. So what he has asked in this problem, determine the normal stress sigma n, shear stress sigma t or shear stress, and resultant stress sigma r. So you know the resultant formula sigma n whole square plus shear stress or square root of sigma n square plus sigma t whole square. Also determine the maximum shear stress. The maximum shear stress you have to calculate. So see, in this the major principal stress given data 100 Newton per mm square, and minor principal stress sigma 2 is minus 60, negative sign due to compressive stress. So the angle of the inclined plane with the axis of major principal stress 50 degrees. Now you can calculate the angle of inclined plane with the axis of minor principal stress. So that is 90 minus 50, 40 degrees. Clear? So now normal stress sigma n, calculate. How do you calculate the sigma n? If you know the sigma 1, sigma 2 and inclination values, then apply this formula normal stress. Sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 into cos 2 theta. So already given the sigma 1 is 100 tensile nature and sigma 2 is 60. That is compressive. So that's why use negative sign. Plus 100 minus of minus 60 by 2 cos 2 into 40. So now we'll get value 20 plus 80 into cos 80 degrees, that is 1.736. So the final value is 33.89 Newton per mm square. So using this equation, you can calculate the shear stress. Sigma 1 minus sigma 2 by 2 to sin 2 theta. So sigma 1 given and sigma 2 already you know, and theta is 40 degrees. So the angle of inclined plane with the axis of minor principal stress. So that the minor principal stress angle is 40, and that is vertical. So major principal stress and this is minor. So whenever the object is subjected to tensile, so one is major. So the angle of inclined plane with the axis of the major, suppose the axis of major this one, so two angles here with the axis this one and the minor axis, so 40 with the major axis this is 50. So 90 minus 40. Like this need to calculate. Now already you have substituted the given values. So in this equation, so you got cos 80 value, calculate and then substitute in this, we will get 33.89 Newton per m square. Sigma t also calculate. Now, so resultant stress already has asked, also determine the shear stress is completed, resultant stress and maximum also completed shear stress and resultant stress he has asked. So how do you calculate the resultant stress? Sigma r is equal to sigma n whole square plus sigma t whole square. So the resultant sigma n 33.89 whole square plus sigma t. So calculate this value and substitute, you will get a resultant stress. So like this, you need to solve the principal stress and strains problems. So these are the references I have taken as Ramamurtam. Title of the book is Strength of Material. Publishers are Dundigal. Publishing Company. And R.K. Bansal, another author, and then a textbook of Strength of Material, and R.S. Kurmi and Gupta. So title of the book is Strength of Materials, and publishers are Rexand and Coleman. So take any one reference for further more clarification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.